Yeah, so recording has been started. Good afternoon. I welcome you all to this live problem solving session for Analog Electronic Circuits course. There are few requests before we begin. First, you'll keep your mics off. If you have any doubts, please raise your hands, as well as you can write down your questions in the chat box. We'll address those questions at the end of the session. And other than that, I would like to make this session as interactive as possible. So if I ask you some questions, or if I want you people to respond, so kindly raise your hands and try to solve with me parallelly, okay? So in between, I'll ask you people for answers. So I hope you people will parallelly solve the questions and we'll learn it together, okay? And we'll address the questions. So if I'm solving a particular question, in that particular question, if you have any doubts, we'll address it just after that question. And if suppose few of those questions are left, or you get few questions afterwards, then you can leave it in the chat box, or you can raise your hands and we'll answer those questions later, okay? With these instructions, let's begin today's session. So let's move on to the first question. So the first question is on your screen. Is my screen visible to everyone? Is there anyone who is unable to see my screen? Can please raise your hands. Okay, since I feel everybody can see my screen, so I'm moving ahead. So the question that we're gonna solve now is this first question. In this question, it is given that V0 is 2.02 volts. The resistance value R is 0.9 kilo ohms. And as we know, the universal diode equation, that is, it is Is exponential Vd by Vt. Here Vt is given 26 millivolt or 0.026 volts. Is is given Is is 2.4 into 10 to the power minus 16 milliamps. So with these values being given, we have to solve and find the value of ID using iterative method. So first of all, what we'll do, we have to assume a value for Vd, that is the drop across diode. Most of the times it is given already, like what you have to assume to make the answers uniform. So in our case, let's assume our Vd to be 0.65 volts. We'll move ahead with this value. So once we know the value of Vd, so what is the drop across the resistance? The drop across the resistance is the cut-in voltage is for diode. So what will be the drop across the resistance? It will be basically the total Vd minus the drop across the diode, right? So it will be basically Vdd minus Vd, or V0 minus Vd. So the value that we will get is 1.37. So this value is 1.37. Now once we got this value, we can calculate the current, right? So from this, what will be the current? It will be V by R So that is 1.37 by 0.9 kilo ohms. Which is 1.522 milliamps. So this is IR1. Now we need to check that with this current whether we are able to achieve the same VD or not, as we have assumed. So we'll backtrack by using this equation. So we know that IR is equal to ID, right? Since diode and resistor are in parallel, so the same current will flow through both the elements. So this current will be same. So now what we'll do, we'll simply backtrack from this equation and we'll find VD. So the expression for VD will be right. So this will be so let's calculate this value. How much is this value? Yes, can anyone please let me know what is the value? Yes, it's 0.946. Okay, so let's move forward. So this is the VD that we are getting. Okay, but this is not the VD that we have assumed, right? So now what we will do, now let's consider this VD and move forward. So we'll go for this was the first iteration, right? Now let's go for second iteration. So for second iteration, we'll use VD as 0.496. So VD to be 0.946. So once VD is 0.946, then VR will be 2.02 minus 0.946. So which is basically 1.074. Okay. So if 1.074 is the voltage, then what is IR? I'll write it as 2. Okay. Since earlier we have written it as IR1, so this is IR2. And this value will be 1.193. Okay, milliamps. Again, this IR2 is equal to ID. So we'll reiterate. We'll again find out the value of VD. So VD is 0.026 ln 1.1933 by 2.4 into 10 to the power minus 16. What is this value? Yes, can anyone please quickly solve this? Yes, it's 0.9397. It's 0.9397 volts. So this is again not equal to what we have assumed, right? So we'll again go for another iteration. Okay, so let's it is iteration 3. So for this iteration our VD is 0.9397. So VR will be 1.08. So IR3 will be 0.997. 1.2. Sorry? Yes, it's 1.2. Okay? 1.2 milliamps. So with this 1.2 milliamps, now again let's reiterate and check whether we are getting the solution. So Vd equal to 0.026 ln 1.2 by 2.4 into 10 to the power minus 16. What is the value that we are getting? So 0.939. So this is what we have got earlier also, right? So hence Vd is 0.939 volts and Id is 1.2 volts. So we could finally reiterate and get the final answer, right? So the correct answer here is option A, that is 1.2 volts. If you want to check further, we can again go for this value and we'll again solve the equation. Then also we'll get 1.2 amperes. Sorry, 1.2 amperes only.
Yes.
1.2 milliamperes.
Yes, madam, please. Excuse me.
Yes.
Excuse me. Madam, go to the top of the screen. Go to the top of the screen.
Okay.
1 minute. Okay. Even ID. Madam, VT is always because already one of the assignment what the sir had given us. I don't understand the first assignment.
Okay.
I don't understand how the VT will be because I will calculate and tell you. The whole problem doesn't matter. But whatever I don't understand, I ask you. Can you show me the first assignment? Not
So
available. This is
first,
this. Yes, yes. VS by VT. Okay. VO 2.02. Okay. This is already given. Okay. 2.04. Okay. So current ID.
so
So yes,
yeah,
yes, but good. Yes, go download. Go download.
okay.
You already every parameters given. VT is already. How can you find VT? VTT means where is the VTD?
Okay. So it's basically V naught. So here
VDD. Okay, okay.
we generally call battery voltage as VDD. That's a
Okay, okay,
convention,
okay.
right? So
Okay,
that's
okay,
why
okay.
I've again mentioned it as V naught as well.
Okay, okay, okay.
Okay?
तो बीडी यहाँ से निकल गया तो वी आर वहाँ पर मेंशन कर दिया गया था बीओ मैंने बेचे थे वी आर मतलब अच्छा बैटरी से अच्छा
Voltage
ठीक है
across resistor is VR. Voltage across
ओके
diode is VD. Current across resistor is IR. Current across diode is ID.
अच्छा मतलब यहाँ पर केवीएल अप्लाई करना पड़ेगा केवीएल पहले अप्लाई करना
यस
पड़ेगा
KVL अप्लाई करना है एंड डायोड इक्वेशन अप्लाई करना है और
हाँ
इटरेटिव मेथड क्योंकि उसमें पहले बात तो क्वेश्चन में भी इट हैज़ बीन मेंशन लाइक यू हैव टू सॉल्व इटरेटिवली तो
हाँ हाँ
इटरेटिव मेथड से करने से क्या होगा यू विल फाइनली गेट वन सिंगल आंसर और वो चेंज नहीं होगा अब यहाँ पे इस वैल्यू के बाद आप इसको कितने बार भी इटरेट कर लीजिए यू विल गेट दीज टू वैल्यूज ओनली
अच्छा
सो इट्स बेसिकली लाइक योर सोल्यूशन हैज़ बीन कन्वर्ज्ड
हाँ हाँ
ठीक
तो
है
ये समझ में इजी हो गया ये तो इजी हो गया उनको समझने से बाद में अगर थैंक यू मैडम थैंक यू फॉर द कोऑपरेशन थैंक यू वेरी मच
Yeah, it's okay. Okay, so we have solved the first question. I would like to know, do you people have any doubts? Is this clear, whatever we have done? Yes, somebody has the mic on. Can you please mute yourself? If you have
अच्छा
some question,
ये
please ask.
मैडम
Yes.
ये मैं एक बात पूछना चाहता हूँ
बोलिए सर.
एक्चुअली इसी टाइम में मैं तो 2 पेपर दूंगा एनबीटेक का 2 पेपर दूंगा अटेंड करूंगा तो इसी टाइम में इसी समय 3 से 4 बजे डिजिटल इलेक्ट्रॉनिक्स पर गया है मतलब उस क्लास को मैंने छोड़कर इस क्लास अटेंड करूँ मतलब हम तो
हाँ
2 एग्जाम देंगे ना इसके लिए
हाँ.
कुछ टाइम बदल
अच्छा
देगा कुछ जगह अथॉरिटी से बात करने
सर
से
सर सर मेरी बात सुनिए अभी 3 से 4 दो लाइव सेशंस हैं और
हाँ हाँ
एक और थर्ड लाइव सेशन भी है शायद ट्यूसडे 6 to 7 और 7 to 8 आई एम नॉट वेरी श्योर लेकिन एक
6 to
ईमेल
7
आया
है
है
ना
या
हाँ हाँ
तो
हाँ
वो भी आप ज्वाइन कर सकते हैं और वो दैट विल बी टेकन बाय सम अदर पर्सन बट दैट इज आल्सो अ लाइव इंटरैक्टिव सेशन
ओ अच्छा अगर इसी पर ज्वाइन नहीं करेंगे तो उस पर ज्वाइन कर सकते हैं
या
अच्छा ठीक
कोई भी एक सेशन आप ज्वाइन कर सकते हैं
अच्छा
इट्स
ठीक है
जस्ट
मैडम
टू
थैंक यू
हेल्प यू विद इट
thank you very much.
Okay. So, dear students, do you have any
Excuse me.
doubts? Yes, yes, please go ahead.
Yes, ma'am, in second iteration, it was 1.193 milliamp. You have missed it 1 milliamp in second
1.193 milli.
iteration.
Yes, it's 1.193 milli only.
But 1.193 into 10 power minus 3 divided by 2.4 into 10 power minus 16. So
No,
final
no,
answer
no,
will be
no,
point.
no, 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 no. Wait, 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 wait. So, IS is also in milliamps. Can you see that?
Okay.
So, I have,
Yeah. Yes.
yeah, there is a printing mistake, so I have mentioned it there. So, that's what I said.
Sure.
We have to keep that in mind. So, this is in milliamps. Okay.
Okay. Thank you.
So, they are cancelled out. That's why I didn't mention. Hope this clarifies. Anyone has any other doubts, or can we move ahead? Okay, let's move ahead. If you have some other doubts, maybe you can raise your hand or keep it in the chat box. We'll
अच्छा
clarify.
मैडम, इसका सॉल्यूशन हम लोग मिल सकता है किसी, आप तो कर दिया है, तो किसी पेज में अगर हम मेल भेज देंगे तो?
सर, ये जो मैं अभी सेशन करवा रही हूँ, इसका
हाँ हाँ।
ये यूट्यूब पे अपलोड होगा, उसका लिंक भी आपके के साथ शेयर किया जाएगा. और
अच्छा अच्छा, ठीक
आई
है
डोंट
ठीक।
नो इफ डॉक्यूमेंट विल बी अवेलेबल और नॉट, बट मैं जितने भी क्वेश्चंस अभी सॉल्व करूँगी दैट विल बी अपलोडेड टू यूट्यूब एंड यू कैन एक्सेस इट देयर.
अच्छा ठीक है, थोड़ी देर बाद मैं किसी जगह से कॉपी कर लूँगा,
श्योर,
ठीक है। कॉपी अगर हो जाए तो अच्छा होगा मेरे लिए, ठीक
बट
है।
ये अच्छा, स्टूडेंट्स प्लीज कीप इन माइंड दैट दिस इज नॉट द करंट असाइनमेंट. These are similar type of questions, but these are not exact same questions. Okay.
ना ना, इसे के सर सॉल्व करने से
Yeah.
इजी होगा।
तो
सॉल्व
इसको
तो हमको लोग को खुद करना है।
yes, yes. So इसको आप you can keep these in mind and you can go ahead and solve other questions. Sorry. Okay, we don't have any questions or any doubts regarding first question, right? Everything is clear, no? So basically we are trying to converge our solution. इसके बाद क्या होगा? If you go and fix these values, no, VD and ID का, no matter how many iterations you go ahead, these values won't change. तो पहले क्या हुआ था? Like I'll explain what happened. In very beginning, we started with 0.65 volts as VD. But when we solved this ID using this particular VD, तो हम लोगों को क्या हुआ कि we got different value of VD over here. So we selected 0.65, but we got 0.946. So this means these two are not like justifying one another. क्योंकि जब VD है, VD is a single value. So when there is a single variable, at a particular time it should give a single value. But here you can see there are two values. That means these two are not justifying each other. So that's why we went for multiple iterations so that we'll get one single value and it will be justified. तो यहाँ पे अगर आप देखेंगे, for third iteration we started with 0.939 and we are finally getting 0.939. और इसको again if you'll go ahead with 0.939, no, and you'll solve another iteration, like let's say iteration 4, तब भी you will get VDS 0.939 only. You will not get any other value. That means your both the values, the one that you have assumed and started the solution, and after solving this universal diode equation, उससे भी जो आपको VD मिलेगा वो सेम मिलेगा. और एक पॉइंट में एक वेरिएबल का एक ही वैल्यू हो सकता है ना. अगर एक वेरिएबल का दो या दो से ज़्यादा वैल्यूज़ आता है, इसका मतलब कहीं ना कहीं कुछ गलत हो रहा है. तो दैट्स वाई वी गो फॉर इटरेशंस. और इटरेशंस करने से हमें क्या हुआ, अब एक ही वैल्यू मिल रही है एंड दैट इज़ द फाइनल वैल्यू. इसका मतलब आपका आंसर आ गया. ठीक है. So the final answer is for VD it is 0.939 volts and for ID it is 1.2 millivolt. Hope this clears. Iteration का concept clear हो गया I guess.
हाँ हाँ हाँ। अच्छा मैडम, एक बार ऊपर जाइए, सिर्फ एक बार पावन प्लीज, ऊपर क्वेश्चन और भी इसका स्नैपशॉट ले लेते हैं, ठीक है? अभी डाउन में चले जाइए, हो गया, थैंक यू वेरी मच। डाउन में चले जाइए, हो गया।
Okay. Now coming to the second question. So in this question, again your V0 is 2.2 volts, and here also R is 0.9 kilo ohms. Here it's already given that VD is 0.65 volts. Sir, can you please mute yourself? Hello? Yeah. Okay. So in this question, it's already given that you have to assume your VD to be 0.65 volts. Okay? And you have to find the current ID. Tick. So यहाँ पे it's not asked that you have to go for iterative method or what method you have to use. ठीक है, first of all. And secondly, universal diode equation का भी यहाँ पे there is no mention, nothing at all, है ना, from in the question. So now moving ahead. So यहाँ पे the first thing that we can find out is basically drop across resistor, that is VR. So it will be 2.02 volts minus 0.65 volts. So this is 1.37. 1.37 volts, right? So current across resistor कितना हो जाएगा? IR, it will be 1.37 by 0.9 kilo ohms. So this is 1.52 milliamps, right? So इस 1.52 में again we know कि the current across diode is equal to the current across resistor since these two are in series, right? So the current across diode will also be 1.52 milliamperes. Got it? So the answer is 1.52. Okay? इसमें किसी को कोई doubt? Do you have any questions in this particular problem? This is very straightforward problem, right? Okay. So moving on to the next question. So in this question, now see, so in every question you have to clearly see what are the values given. Here the cut-in voltage is 0.7, it's not 0.65. So it will be mentioned almost in every question, or otherwise on the top of the on the top of your papers, question papers, sometimes there are notes, right, regarding your exam. So in those notes also there are few values, few universal values which are given. So suppose if this particular value is not given in your question, then assume its value to be this. So those things you have to keep in mind, they are very important. So in this particular question our VD is 0.7 volts, okay? So what it says, we have this circuit. In this R1 is 0.1 kilo ohm, R2 is 2.1 kilo ohm, okay? So what is the current through R2? That is what we have to find out and report it in milliamperes. So इसमें the current that is coming from here, let's distribute this as ID, I1 and I2. So by applying KCL, we'll have ID plus I1 as I2. This is clear, right? And secondly, let's say our diode is on. If our diode is on, in that case, if diode is on, then voltage across R1 is 0.7 volts, right? So the voltage across R2 will be 6.3 volts, right? So let's see what we are getting for ID. ID is I2 minus I1. So I2 is 6.3 by 2.1 minus this is 0.7 by 0.1. This will be 3 minus 7, which is minus 4, right? So ID is minus 4 milliamps. Now since the current across diode is negative, so this assumption is false. What is the assumption that we have taken? That the diode is on, right? This is the assumption that we have considered, that our diode is on, but we are getting current to be negative across the diode. That means this assumption is false. So the diode is off. Okay, so once the diode is off, that means अब हमारा circuit क्या हो जाएगा? The circuit will simply convert to a voltage divider. With this being open circuited, right? So now what will be the current across R2? So current across R2 will be simply R2 by R1 plus R2 upon V, right? Vx. This will be the current. Is there any doubt in this? Or this will be V into R1 plus R2 by R2. है ना? So what is the value of I2 that you are getting? Can you please let me know what is the value of I2? Sorry. $7.33. No, it's wrong. What are the other answers? Let me see. Yes, it's 3.18. So the answer is 3.18 milliamps. And this is the option, right? Isme any doubts? In this solution, do you have any questions, any doubts? Is this solution clear? Is this problem clear? Sanjeev, yes, you can unmute yourself if you have any doubts. Yes.
Yeah, ma'am, I want to know that R1 and R2 are in series with Vx.
Yes.
Then why we are taking this V by R2 by R1 plus R2?
It's simply voltage division, right? Okay, to make it simple, so first of all, what will be the total current? Total current will be Vx by R1 plus R2, right? Or you can understand it like, or you can understand it as you want the current I2. This is I1. Sorry, we can directly go for this, no? Vx by R1. Oh, yeah, thank you so much. Yes, something is wrong. Yes, series में है ना, तो it's direct R1 plus R2, right? Vx by R1 plus R2. Yes, please note. Thank you for pointing this out. Yes.
Thank you, ma'am.
Thank you so much. Yes. So this is in series,
अच्छा
right?
मैडम,
Same current flow होगा ना
हेलो,
through R1 and R2. Yes, sir.
अच्छा मैडम, यहाँ पर है वोल्टेज अक्रॉस R1 0.7 वोल्ट।
Yes.
एक बार ऊपर जाइए क्वेश्चन में, एक बार ऊपर जाइए ऊपर क्वेश्चन में। अच्छा, तो R1 का वैल्यू 0.0, क्योंकि R1 तो है, वो तो 0.7 वोल्ट कैसे हुआ है ये? क्योंकि ये तो डायोड इज ऑन, डायोड का तो इंटरनल रेजिस्टेंस है 0.7 वोल्ट,
नहीं, यहाँ
मतलब वोल्टेज
पे
का।
वेट, यहाँ पे डायोड का कट इन वोल्टेज इज गिवन 0.7। तो जब कोई भी डायोड अगर ऑन होता है तो उसका
हाँ,
आपको अगर स्पाइस मॉडल
ब्रेकडाउन वोल्टेज होता है 0.7 वोल्ट।
तो
हाँ,
उसका
ब्रेकडाउन
0.7
वोल्टेज।
वोल्ट और फिर एक सीरीज रेजिस्टर। पर यहाँ पे सीरीज रेजिस्टर का कोई बात नहीं हुआ है, सो विल कंसिडर नॉर्मली
हाँ,
कट इन वोल्टेज। तो 0.7 वोल्ट का यहाँ पे एक बैटरी आ जाएगा बेसिकली, और वो क्या है
अच्छा
R1 के पैरेलल में है, तो R1 का अक्रॉस ड्रॉप कितना होगा? 0.7 वोल्ट्स, है ना?
अच्छा
तो
अच्छा
इसलिए ये हो गया।
अच्छा,
एंड
ठीक।
थैंक यू फॉर पॉइंटिंग दिस आउट। सिंस दीज टू आर इन सीरीज, तो यहाँ पे तो डायरेक्टली Vx by R1 plus R2 हो जाएगा ना, क्योंकि सेम करंट विल फ्लो थ्रू बोथ द रेजिस्टर्स। So we'll simply find out the total current, and that is the current flowing through each of these two resistors.
अच्छा,
So
एक
that's why
मिनट मैडम, यहाँ पर हम लोग डायोड को क्यों हटा दिया?
डायोड को, सर हम लोग पहले क्या बोल रहे थे कि डायोड का दो कंडीशन हो सकता है, या तो डायोड ऑन हो सकता है या डायोड ऑफ हो सकता है ना?
अच्छा, हाँ,
ऑन होगा तो हम लोग उसको एक बैटरी से रिप्लेस कर रहे हैं जो कि 0.7 वोल्ट का होगा। ऑफ होने से क्या
हाँ,
है, बेसिकली ओपन सर्किट हो जा रहा है डायोड, है ना?
अच्छा अच्छा, हाँ,
तो ये सिचुएशन है। तो हमने
ओ,
पहले अज्यूम क्या किया कि लेट द डायोड बी ऑन। तो ऑन होने से क्या सिचुएशन है कि मेरा R1 के अक्रॉस जो वोल्टेज है इट विल बी 0.7 वोल्ट्स, और
हाँ,
R2 के अक्रॉस रिमेनिंग वोल्टेज। तो उससे जब हम KCL सॉल्व कर रहे हैं तो क्या हो रहा है कि डायोड के अक्रॉस जो करंट है वो नेगेटिव आ जा रहा है। नेगेटिव करंट का मतलब क्या होता है कि डायरेक्शन इज ऑपोजिट। अगर मेरा ID अभी इस तरफ मैंने लिया है तो -4 का मतलब मेरा ID का डायरेक्शन कुछ ऐसा है। सो इफ़ माई डायरेक्ट, अगर डायोड का करंट ऑपोजिट है तो ये कभी भी पॉसिबल नहीं होता एक डायोड में। डायोड में सिंगल डायरेक्शनल फ्लो होता है, तो
अच्छा
डायोड
अच्छा,
का करंट कभी भी ID के डायरेक्शन में ही होगा। तो क्योंकि यहाँ पे नेगेटिव आ रहा है, इसका मतलब क्या हुआ कि हमारा डायोड ऑन नहीं है। तो बेसिकली डायोड क्या है, ऑफ है। तो हम इसलिए क्या कर रहे हैं, डायोड को ऑफ करके फिर सॉल्यूशन फिर से सॉल्व कर रहे हैं टू फाइंड द करेक्ट सॉल्यूशन और करेक्ट आंसर। तो इसलिए इसका आंसर विल बी 3.18।
थैंक यू मैडम, थैंक यू।
Pradeep, what do you want me to repeat? Can you elaborate?
Ma'am, actually I joined late, ma'am, so that's why, ma'am, I didn't understand.
Okay, so we are at this third question. So in this particular question, actually you will get this recording also, but I'll explain you very quickly. So this is the circuit, and you have to find the current through R2. That is the question. Okay? So first things first, we have a diode and its cut-in voltage is given. So what we are considering, so when there is a diode, there are two conditions. Diode may be on or it may be off. So we are moving ahead with diode being on. So once the diode is on, then if the diode is on, so it will be replaced by its cut-in voltage, a battery of 0.7 volts. That's how we replace it. if we talk about its P-SPICE model, so we replace it with the battery and its internal resistance. But since यहाँ पे internal resistance का कोई भी बात नहीं हुआ है, so we'll replace it with simply a battery of 0.7 volts. ठीक है? So what does that mean? कि तुम्हारा इस डायोड की जगह पे there is a battery of 0.7 volts, which means कि R1 के across तुम्हारा voltage कितना है? 0.7 volts. ठीक है? तो रिमेनिंग वोल्टेज ऑफ दिस बैटरी वो कहाँ जाएगा? R2 के अक्रॉस जाएगा. 0.7 अगर R1 के अक्रॉस है तो बचा हुआ R2 के अक्रॉस जाएगा. तो R2 के अक्रॉस वोल्टेज कितना हो जाएगा? आउट ऑफ 7 वोल्ट्स दिस Vx इज एक्चुअली 7 वोल्ट्स, राइट? तो 7 में से 0.7 जाने से 6.3 वोल्ट्स. अब उसके बाद हम लोग क्या कर रहे हैं? हम लोग KCL लगा रहे हैं इन बिटवीन दिस डायोड करंट अक्रॉस R1 एंड करंट अक्रॉस R2. तो जब हम लोग KCL अप्लाई कर रहे हैं तो क्या हो रहा है कि जो डायोड के अक्रॉस करंट है इट्स कमिंग आउट टू बी -4 मिली एम्पियर्स. -4 मतलब माइनस इन करंट मतलब इट्स डायरेक्शन इज ऑपोजिट. तो हमने पहले जो डायोड के करंट का डायरेक्शन लिया था वो रेड वाला मार्क दिख रहा है उस डायरेक्शन में लिया था, फ्रॉम लेफ्ट टू राइट. लेकिन इट सेज कि तुम्हारे डायोड का करंट जो होगा वो राइट टू लेफ्ट है. बट दैट इज़ नॉट पॉसिबल इन केस ऑफ अ डायोड. अगर ये रजिस्टर होता या कैपेसिटर होता या इंडक्टर होता तो उसमें ये चलता, यू गेटिंग अ नेगेटिव करंट इज़ फाइन. बट डायोड के केस में यू हैव यूनिडायरेक्शनल फ्लो. एक ही डायरेक्शन में देयर इज़ फ्लो इन अ डायोड. सो अदरवाइज जब होता है, जब डायरेक्शन को चेंज किया जाता है करंट का, सो दैट इज़ नॉट पॉसिबल इन अ डायोड. तो इससे क्या हुआ कि द अजम्पशन दैट वी हैव टेकन, दैट इज़ द डायोड बीइंग ऑन, दिस इज़ नॉट करेक्ट. दिस इज़ एक्चुअली अ फॉल्स assumption. So since this is a false assumption, so we'll go for next assumption. अगर डायोड ऑन नहीं है तो डायोड क्या होगा? ऑफ होगा. So the next thing is diode is off. So once the diode is off, डायोड के ऑफ हो जाने से क्या हो जाएगा? सिंपली यहाँ पे एक ओपन सर्किट आ जाएगा. और ओपन सर्किट का मतलब R1 और R2 सीरीज़ में आ जाएंगे. और R1 और R2 अगर सीरीज़ में आ जाएंगे तो उनमें से सेम करंट फ्लो होगा. और वो करंट कितना होगा? टोटल करंट के इक्वल होगा. सो वही तो I2 का वैल्यू विल बी Vx by R1 plus R2 एंड द आंसर इज 3.18 millivolt. क्लियर?
Yes, ma'am.
Okay. Any further questions? Any further doubts in this question?
No, ma'am.
Okay. So moving on to next question. So in this particular question, what is it given? That consider a non-ideal diode with standard diode equation. Standard diode equation मतलब ID equal to I is exponential Vd by Vt. Okay. Now it says that Vd changes by 2 millivolts. Delta Vd is 2 millivolts. So what is the change in ID? We have to find delta ID. Delta ID by delta Vd मतलब change in ID with respect to Vd basically. Or it's also given that Vt is 26 millivolt. So इसमें if we'll see like delta ID by delta Vd, then we'll get, we have to simply differentiate this equation with respect to Vd, right? So Vd by Vt, na? Yes, Vd by Vt. So this is the expression that we are getting after differentiating. So that means this is actually this expression is as it is, as ID or ID that into VD by VT. यहाँ पे ID has been already given to be 1.7 milliamps. So this will be 1.7 into how much was the VD change? So it was 2, and what is VT? It is 26 milli. So 0.02, or actually both are in milli, so we can write it simply as 26. And this is in milli. So let's solve this. Yes, it's 0.13, right? This is 0.13, and the answer is asked in, we have to report it in microamperes, right? So this is in milli. So micro के लिए it will be 0.13 milli into 1000. So that means 130 micro. So the change in current with respect to change in voltage is actually 130 microamperes. Okay. .7 actually 1307 है. So if we want to be very precise, so it is 13077. So if we go ahead, so it will be 130.77. So this is the exact answer that has been given in your option, right? To be very specific, this is the answer which has been given, and this is the option. Okay, so any doubts in this question? Do you have any concerns or any doubts in this question? Okay, so hope this question is clear, as I cannot see any raised hands. So moving ahead with next question. Okay, so in this question, what is given, like in the circuit below, the diode operates according to the standard diode equation. Standard diode equation means again the same equation. Okay, here IS is also given 5 into 10 to the power minus 11 milliamps. VT has been given to be 25 millivolts, and R is given as 4.92 kilo ohms. So a voltage V of 1.24 volts is applied to the circuit, and the current through the resistor is measured. Now if the voltage is increased by 10 millivolts, so delta V is 10 millivolts, so what will be the current increase, like delta I? This has been asked. Okay, so for this question, first of all, in this question again we have to consider a VD, drop across voltage. So let's say the drop across this cut-in voltage across the diode, which is 0.65 volts. So इसमें VD is equal to 0.65 volts. So if drop across this diode is 0.65, so what will be the voltage across the resistor? The voltage across the resistor will be much is this? Oh, sorry, voltage across the resistor as well as the current. So this will be IR, and VR is 1.24 minus 0.65. So 1.24 minus, this is 0.59 volts. One 1199 or milliamps or 0.12 milliamps. This is the current across the resistor. Now this is the current across the resistor, and if we want to know that what is the intrinsic resistance of a diode, it is actually Vt by Id. And since diode is in series with resistor, so IR will be equal to ID. Okay, so now calculating RD, it will be 0.025, I guess, right? Yes, 0.025 upon 0.12 milliamps. So it is 25 by 0.12. So RD is, no, it's not 216, it's 208.33 ohms. Can you please recheck? There might be some calculation mistake over here. It's 208.33 ohms RD. Okay, so the total resistance कितना हो गया of this whole circuit? Total resistance is actually R plus RD, which is 4.92 kilo ohm plus 0.2083 kilo ohm. So it is 5.1283 kilo ohms. So this is the total resistance. Okay, so if this is the total resistance, then what is the voltage increase is 10 millivolts, right? Delta V is 10 millivolts. So delta I will be delta V by इसको let's say R total. So it will be delta V by R total. So this will be 10 millivolt by 5.12833 kilo ohms. So we have to report the answer in microamperes. Okay, so what is the final answer? 1.95. Yes, correct, it's 1.95 microamperes. So please be very careful with the units, whether it is milli, micro, nano, okay, mega, pico. You have to be very careful with the units. Okay, what's the time now? It's already 3:55. Do we have any questions regarding today's session, or any question till now that we have solved? There are no questions in chat box as well, and all the issues in the chat box have been already solved. So we could finish 5 questions till now. Do you want to continue, since we are already at close to 4 o'clock? Okay, sure. So let's go ahead with the next question. Okay. Okay, so let's take up this question. So this is actually the follow-up question. So here also this resistance is 4.2 kilo ohms, right? So this is the last question that we'll take up for today, okay? So in this question, what we have to do, first of all, let's note down the information that is given to us. So it's given that V0 is 1.24 volts. The small signal is, let's say V0 is 10 cos omega t in millivolts. Okay, this is in millivolts. Omega is 1001 kilo radian per second. C is 5 nanofarad. R is 4.92 kilo ohms. Okay, so what we have to find, like, what is the amplitude of the ripple voltage across a resistor? So since this is a single diode, so this circuit will somewhat behave like a half-wave rectifier, right? So how will the output waveform will look like? So this is how it will look like, right? So what we have to find out, what is the amplitude of this ripple voltage across the resistor. Okay, so this peak, we have to find out what is the value of this peak across this resistor. Alright, so for this, what we'll do, we'll find out that what is the gain across this resistor. So what is the gain across the resistor R? Okay, this is what we'll find out. For this, what we'll basically find out is transfer function, then gain. So transfer function method, VR by Vin. This is what we have to find out. Okay, so let's replace this diode with resistor. So for transfer function, we know that we need impedance based circuits, right? So we'll convert this whole circuit into impedance based circuit. So if I make this circuit a simplified circuit, so this will somewhat look like this. Let's say this is RD and this is Z, right? Where the Z consists of R parallel to 1 by j omega c, or if we solve it further, R into 1 by j omega c by R plus 1 by j omega c. So Z is equal to R by 1 plus j omega RC, right? So we have to find VR. So VR is equal to VC equal to VZ. This is clear, no? Because whatever is the voltage at this point X, this is the same voltage across this resistor R as well as the resistors as well as the capacitance C or the impedance Z, because this is what I am saying to be as Z, this combination of R and C parallel, this is Z. So इस point पे whatever voltage we have, let's say it is Vx, so Vx is the voltage drop across this whole Z as well as it is the voltage drop across this R as well as C. Okay, so what will be VR by Vn? This is basically Z upon Rd plus Z, right? And we know the value of Z. It is R by 1 plus j omega Rc by Rd plus R by 1 plus j omega Rc j omega Rc. This is VR by Vn, R by Rd plus j omega Rc into Rd plus R. So if we take mod of VR, this is basically R upon okay, let's take out the common things first, so it will be easier and simpler to solve. Okay, so let's make it simpler. So taking out R from numerator, so we'll be left with 1, and from denominator let's take out R plus Rd. So here we'll be left with 1 plus j omega R into Rd by R plus Rd, right? And if you look into this carefully, this is basically R parallel to Rd, right? So here it will be R upon R plus Rd 1 by 1 plus j omega C is also here. Let's see. C j omega C R parallel to Rd. Okay, now we'll go for mod VR by Vn. So this will be R upon R plus Rd 1 by root over 1 plus omega square C square R parallel to Rd square. Okay, now here you have to simply substitute all these values, and Rd you have to take from the above question. So what in last question we have seen the value of Rd was, how much was Rd? It was 208.33 ohms, right? So we have to substitute that. So in this formula you have to substitute all the values, then what you will get is 0.6 it is 0.6783. This is what you'll get. Okay, so this is the gain across R. Now once you have solved for the gain, the next thing is you have to multiply it with the input to see what is the output that you will get, right? So VR will be simply 0.678381 into Vn, right? And Vn maximum amplitude is 10 millivolts, amplitude of our input sine wave. So VR will be 0.67881 into to 10 millivolts, that is 6.78381 millivolts. But here the answer is asked in microvolts, so we have to multiply it with 1000. So VR is actually 6783.81 volts, sorry, microvolts. Microvolts, yes. And this is the final answer. This is your option B. Understood? Any questions? Any queries regarding this particular problem? Hope this problem is clear. Yes, I'll scroll down. So it's already 4:06 for now. So I guess we can stop here for today, and we can meet in next session if you don't have any doubts. Yeah, these are the problems that I have particularly selected for this particular session. So we have solved 6 questions by now, and other questions you people can solve from assignments. Okay. So the next session is again on Sunday. It will be from same during the same time, that is 3 to 4, and we'll again continue there, and we'll take up some problems for the upcoming week. So for this week we have solved this particular six questions. Hope these 6 questions help you solve the assignment that has been given for this particular week. And yeah, hope you all enjoyed and learned this session, and the session was helpful for you all. And that's all for today. Yeah, you will get this recording. I'm recording this session and it will be uploaded to YouTube, and you'll get the recording. Anything else? So you people can go ahead and solve your question. Which problem are you talking about? This is the last problem that I'm taking up for today. It is not all the questions from assignment has been solved. Brief idea about question 8 in assignment. Are you talking about this current assignment? Which question number 8 are you talking about? Okay, the current assignment, question number 8. When will be the regular classes? So regular classes, you people are getting these recorded lectures, right? You have to go through those lectures, and we will have these live sessions every week, and then you have to solve the assignment and submit. So those recorded lectures are only like regular classes. It's just that rather than being a live session, they are recorded lectures, that's it. No, assignments won't be mailed. Assignments are there in Swayam, that NPTEL site, right? Where you log in, where you see the week-wise lecture series as well as your assignments. So week 2 you will get just after finishing week 1. So once the week 1 is finished, the next moment week 2's lectures will be uploaded. 7, 8, 9, 10. What is this 7, 8, 9, 10? Sorry. So the remaining problems you people can solve. Like we have selected 6. So these 6 are not like the first 6 problems in your assignment. That's not the way. We have selected few patterns which are close to the assignments, but other remaining problems you people can solve, try and solve. And if you are stuck, you have another live session coming up on Tuesday, so you can ask there. No, for today we have 6 questions scheduled, and we have finished these 6 questions. Actually, there is another question which was left, but since time is up and students have already left, so we could finish up to 6 questions, so that's fine. Okay, you want to see the last question which was there in the slot. So this was the last question that was there in the slot. This is very simple, very basic question. So here just you have to find out the current across the diode. So this was the one pattern which was last, that was left. So that's it. Yeah. So other questions you people can try and solve, and you can ask in the coming session. There is another session on Tuesday, if I'm not wrong. There you can ask, and we can also discuss if we have time left next week, then we can also discuss that. So that's all for today. Thank you everyone. Do you have any further concerns, any queries? Participants who are left, do you have any concerns, any queries? Thank you. Thank you so much.
Thank you.
Link for Tuesday has already been shared with you people, right? In a mail. So in a mail there were 3 links. 2 were for Sunday 3 to 4 and 1 link for Tuesday. So you can go through that mail and you will find the link there. Okay. I hope no further concerns, no queries. Welcome. So hope you people have a wonderful day ahead, and hope this session was useful and nice interacting with you people. So let's continue this session every week, and let's make it a success. Okay, thank you everyone. Bye. Not very sure will they solve the same questions, because I won't be taking that session. It will be taken by somebody else. So they'll be solving the session, and it depends on them, like what are the questions they want to take up. But you people can join and see if they are the same questions or there are some different questions, then you can get more insight into it. Okay. Bye all. Yeah, welcome.